Good afternoon, and welcome to another episode of Better Together at Science with Shinrai Sensei. Today, we're going to go over some basics of geology, which is the most fundamental of the earth sciences, right? And we're just going to go over the three different kinds of rock, right? The three main kinds of rock. They're just categories that other rocks can be organized into, but these are just the basics, so we'll go over that and kind of tell you some classification information about these rocks and how they form. So, the most basic of these rocks is going to be sedimentary rock. Think sandstone or limestone. Very easily broken, very frail, very prone to erosion. But, you can also see this layered effect to them. So you'll see easily eroded or broken and layers, right? And it's due to the way that sedimentary rocks form that creates these layers that are mentioned in that, right? So the layers are a result of, it's basically just imagine you have a time machine, right? And using that time machine, you go into the far-flung future. You go, let's say, I go 10 million years into the future. My property will probably be sitting a few thousand feet higher or lower than what it is today. In a few million years, the property that I'm sitting on right now will be a few thousand feet higher or lower than what it is today. And that's going to be due to erosion. That's going to be due to the depositing of materials. So rivers and lakes and such like that are very big hotspots for depositing materials. Deserts and river edges are going to be very prone to erosion, right? So look, for thinking of a good example of erosion, look at the Grand Canyon. The Grand Canyon was carved by the Colorado River over the course of a few tens of thousands of years, or maybe even a couple million years, right? So we have all that material that the Colorado River eroded from the Grand Canyon gets deposited somewhere else. And that deposit eventually will set an area up and create land. And this is one of the couple of ways that you'll see land created. New land will be created either through a sedimentary process or through an igneous process, right? And the sedimentary process, like I said, you have rivers, you have the wind, you have things like that will erode material away and wash it away and move it somewhere else and create new land. So, like a river delta. Well, that river delta, the coastline where that river delta dumps into the ocean, was probably receded back a number of miles a few thousand years ago, right? So let's say 20,000 years ago, the Everglades were probably much further inland, and the place that we would think the Everglades would be today, you'd be out there with a life vest on trying to find any amount of land and probably dodging some very large sea predators in the process, right? Same with Louisiana. Much of Louisiana a few thousand years ago probably didn't exist. There's Lord knows how many square miles of land that have been deposited, let's say, over the course of 50,000 years, even. Who knows how many square miles of land the Mississippi River has deposited at the end of that delta as it dumps the water that it's the water washes into the ocean, but all that material that the river's been carrying, it gradually deposits that material down the river, right? But the majority of that material is getting deposited at the delta. It will, mostly because of the fact that it's got fresh water trying to mix with salt water, and it will kind of slow the water flow down because of the process of diffusion and osmosis and such like, or well, diffusion, I should say. Osmosis is a different thing that's related to diffusion, but not the same. Through the process of diffusion, though, that water will have to slow down in order to diffuse properly into the salt water of the ocean. And when it slows down at the end, the water will deposit all of the sediment that it has built up. And that sediment builds up and up and up and up and up and creates new land. And over the course of a few thousand more years, that land will become even more solid because of the pressure of more land building up on top of it. So if I was to just come back to my property in a few thousand years, let's say I don't live next to a river, but there's some lakes around here. My property could be in a lake in a few thousand years because of the fact that over time, the pressure will compress all the layers of ground down into one layer. That's what sedimentary rock is. You have just all this ground is just so heavy that it kind of just squeezes out everything that might occupy space in between the sediment. And so you have a lot of air, a lot of water, a lot of just space in between the individual pieces of sediment that will be pushed out by the overwhelming weight of that sediment over time. And eventually it will all just mesh together and create one solid rock. And that solid rock will, while not necessarily be the most sturdy rock, and not most certainly not a rock that you could anchor something to like bedrock or something like that, it will be a lot stronger than like the topsoil that it once was, right? So there's sedimentary rock, easily eroded or broken, and it forms in layers because of the fact that it is literally just layers and layers and layers of soil, sand, gravel, clay that just get compressed over thousands and millions of years into a rock, right? That's all. I know I overcomplicated that, but I wanted to give you guys detailed examples and detailed explanations. Now, sedimentary is one way that new land can be created. This is one of the only two ways that new land can be created. Like I said, at the end of a river deltas create entire new ecosystems and entirely new swaths of land that didn't exist before. But the original way that land is created, the one way that land is always created where it doesn't exist already, and this is sedimentary, just takes land and puts it somewhere else. Igneous creates it. And I know creates is not the right word. It's more just takes stuff from inside the earth and puts it on the top. And so you have that process. And then over the course of millions of years and continental drift, material gets recycled, right? But igneous rock forms new land. Sedimentary rock forms used land. Best way to think about it, really. But igneous rock is formed by the cooling of lava, right? So igneous rock comes from volcanoes. The most typical form of rock that you can think of, volcanic rock. I mean, typical in the sense of where you think rocks come from. It's not mommy rock met a daddy rock and they fell in love. It's that a very hot, burning, engine that fuels our planet is generating so much heat that all the way up until just the very top of the planet is cool enough to stand on, but everything, within a few miles of that top cool layer is molten or straight up liquid. gets spit out on the surface, and that's where you get igneous rock, right? So igneous rock forms by cooling lava. Think of the lava flows that are formed at the, I think it's called the Kilauea, but don't quote me on that. Kilauea volcano in Hawaii, right? The shield volcano known as Kilauea. It's just constantly depositing material, and it's the reason that the islands are as big as they are, right? It created those islands. It's a hot spot that is sitting underneath the ocean, and the Pacific continental, plate is sitting over top of that hot spot and super slowly moving. But that hot spot's constantly pushing lava out and making land over the ocean. And so eventually the island of Oahu, where the volcano is currently active and currently expanding the island of Oahu will either become kind of a miniature, subcontinent type of thing and become an extremely large island, or if there's any sudden shift to the Pacific plate and transfers that lava to a makes that hot spot sit under a fresh new spot that's never had an island before, or unless the hot spot goes away entirely, Oahu could become, depending on how continuous that hot spot flows, could just become one gigantic island that will, maybe over the course of millions and millions of years, erode into the sea. But for now, it's going to get bigger, right? So igneous rock, think of the lava flows on Oahu with Kilauea, and there's your igneous rock. It's usually very dark in color. If you see it when it's freshly formed, it honestly looks like someone just melted something, like melted glass, melted plastic or something like that, and poured it on a surface. Similar look, because that's basically what it is. It's just melted rock that is being poured over a surface, right? And the igneous rock is the purest of the rocks, right? It is going to be, all these rocks are just melted down until they turn into one rock, basically. You'll have different rock types depending on where the rocks are coming from and, the volcano's chemical composition, but the igneous rocks, just the rocks that come out of those are melted down until they just form one kind of rock, right? Which brings us to the kind of rock that's, well, many different kinds of rock, or it could be parts of the same kind of rock, right? Metamorphic rock. Now, metamorphic rock is going to be formed from processes deep under the surface, right? So you have the sedimentary rock is going to be the surface compressing itself down and down and down and down over however many years, however many thousands of years, until eventually it's just solid. But the metamorphic rock, it requires pressure and heat. Igneous rock just requires heat. Sedimentary rock just requires pressure. But metamorphic rock needs pressure and heat. And one of the best types of ore that you can think of for a metamorphic rock or crystal would be diamonds. Diamonds form, at least naturally, diamonds form under extreme heat and pressure. So they will be not quite in the mantle of the earth, where the lava that forms igneous rocks comes from, but they will be in a very, very deep portion of the crust that is close enough to the mantle that you will feel the heat from the mantle. It just won't be full on melting you. But then you get to the sedimentary effect of just constant weight being pushed down on you. So you have heat coming up and melting, stuff, or at least heating it up so that it doesn't necessarily doesn't necessarily, it's not necessarily solid, but it's not necessarily liquid either. It's not hot enough to turn full-blown into a liquid rock, but it is not cool enough that it can just sit there and be solid and, you know, just resist the pressure like, you know, granite and marble and stuff like that will resist great deals of pressure. But the metamorphic rock will eventually just coalesce, and a lot of times the metamorphic rock is some of those really, really cool looking rocks where you see like crystalline structures buried inside of another rock or something like that. That's where metamorphic rock comes from. It is just this rock got warm and it didn't melt, but it allowed it to kind of form into and coalesce into something else, right? A lot of crystals form in metamorphic conditions. Metamorphic conditions are what will form the majority of crystals and jewels and stuff like that we think of are formed in metamorphic conditions, right? So metamorphic rock requires pressure and heat. Igneous rock just requires heat, then cool. And then sedimentary rock literally just requires pressure. That's the basic summary of what these rock types are. All of these are susceptible to erosion no matter what. It's just sedimentary rock is particularly susceptible to erosion because it itself comes from materials that were eroded. So that's why you're going to see sedimentary rock easily erode, right? If you guys do have any questions about this material, or if you have anything specific you would like me to cover in another episode, please leave it in the comments section below. For now, that has been Shinrai Sensei on a little bit of the basics of geology and the 3 types of rocks. I hope to see you guys next time.